Hello. Okay, now I'm going to talk about the logical configuration of this lab. Okay, so first thing is from the ISP to the Dream Machine Pro. It's just a connection from my cable modem to this guy. It's nothing special. And then from my Dream Machine to my MDS, which is my 3750X, again, it's just a simple connection. Nothing special. On my lab switch, however, it is only connected to the MDS, the main distribution switch, via a VLAN 1. So no other VLANs can get from my lab to my MDS, which is where my home network is at. However, my devices in my lab can reach the internet where I allow them to. And in some cases, it's necessary for them to reach the internet, such as an external DNS server. Okay, so the lab switch. The lab switch is connected to, we'll talk about the 3650 switch first. That's just a Cisco 3650. I use that in the DNA lab. And that's a physical switch. And I have that link set up as an access port in VLAN 5. And I will show you that now. So that will be this one. So these links here are something separate. That's not part of, I'll call it lab production traffic. This is out of band, so I don't need to talk about that right now. I am just going to talk about the in-band traffic. So here is that port. VLAN 5, that's it. It's just connected to it. Nothing special there. Going back to this diagram, it's connected to 2 ESXi servers. I'll show you ESXi server 1's configuration. It's set as a trunk, allowing all VLANs. If I need to prune them, I can, but it doesn't really matter. So that's going to be maybe I passed it. It's not it. There it is, right there. Okay, so this is server 1 right here. And it's just a simple trunk configuration. And then server 2 is the same thing. So nothing special about that. There is magic later on, and that's when we get to the lab router. But that's how the lab switch is set up for those connections. Now I'm just going to go through the rest of the configuration of the lab switch and talk about it. I have AAA set up, just local authentication. I have a domain name set up, which is just my lab domain name. You can't reach that on the internet anywhere. So that is that. Remember how I said on the diagram I have VLAN 1 set up that connects to the MDS? Well, that's where these ports up here that I labeled management, those are in VLAN 1. So there's a physical port on the back of these switches that is labeled management. And I have a cable plugged into them. And then it just flows through the lab switch and goes to the MDS and out to the internet. Or if it doesn't need to go to the internet, you know, just from my home PC. Okay, let's see. These 1841s are just routers. I just have them set up with no IP routing, and they're just my test devices. I just run ping from them. That's it. So they're my test PCs. Let's see. These are just some more links. I can configure them and use them however I want. I don't have any configurations on it other than the generic one because I don't need to at this point. This is my router configuration. The 1921, that's my lab router. It's just a trunk that allows everything. Nothing special. This gigabit 048 is just that link that I showed you here. Right here. Just this link. It's just a VLAN 1, nothing special. I have an IP address set up so I can reach these using my internal network, which is 192.168.1.0/24. So I have my lab switch using this IP address, which that IP address belongs to my Dream Machine, which is over here. So that's where that IP lives, and that's where this guy's pointed. Yep, that's it for that configuration. All right, so where all the magic happens is in the lab router. I got access list configured, I've got DHCP configured, DNS, NTP, all that stuff. And it all works. And I'm going to explain that right now. We'll go to lab router. I'll get logged into it. Let's see. I don't have AAA configured. It doesn't matter. All right, so this is part of DHCP. The first thing you do is you set your excluded addresses. I'm going to go back to this and skip it right now. So for this example, I have a whole bunch of pools set up, and I've got a lot more than this configured, and I can expand this for as many as the router will take. I also have the default router set up. So on this router, which I'll show you later, I have sub interfaces set up, and those sub interfaces are those IP addresses. And I have DNS set up, which the DNS server can be any IP address on this router that's reachable by whatever device is trying to reach it. It doesn't have to be 99.99.99.99. can be literally any IP address on here. But I'm trying to keep everything standardized, kind of like you do in production. I'm using 2 IPs universally. It's either the 99s or 183.1.1.1. Okay, anyways, so for this one, I have my VM network configured. And a DHCP says, yep, we're just going to do DHCP for that entire address space. But then I have the excluded addresses somewhere. Oh, here they are right here. So those are the lower ones, and these are the higher ones. So I guess it'll just be easier to talk about them if they're together like that. But it doesn't matter. But anyways, and so I just have a block between .2, or excuse me, .2, between .50 and including .60 set aside for DCP addressing. That's it. I don't need any more. If I need more, I can expand this and change these commands. But anyway, so they just narrowly, it basically allows me to use any IP address I want within my networks without worrying about a DHCP address conflicts without me realizing it. All right, so the next part of the configuration, you can see I got this defined a lot. This particular one up here, the DHCP pool network 97, is one that my DNA center uses, and so I also have that configured and used. All right, so that's concludes DHCP. Now DNS. In order to configure DNS, you have to define a domain list, which I'm using CiscoWorldTour.com. You have to define a domain name, and so you'd say, hey, this router's domain name is CiscoWorldTour.com. And then I can just define however many hosts I want. So my DNAC would be, DNAC.CiscoWorldTour.com, and goes with this IP address. So all I have to do now is just ping that, and that will resolve. Now, these IP addresses are the public DNS servers. These are Open DNS, which is owned by Cisco now. So now I can go to my DNA center, and I'll show you that right now. And I can do, let's just do redhat.com. And it resolves it. It pings successful. Bob's your uncle. Okay, so going back to the router. Let's see, none of the rest matter. So that's DNS. None of that matters. Okay, so here we go. So gig 00, and I'll show you on the diagram. We are here. Gig 00 connects to my lab switch. Gig 01 connects to the MDS. Okay. So gig 00, well, technically is not a trunk, but I'm using it like a trunk. But anyways, I have VLAN 3 uses this IP address range, and NAT I'll get into a little bit later. So I'm going to skip that for now. But anyways, that's that. And then just rinse and repeat. And again, for VLAN 97, just defined the encapsulation, gave it an IP address. Bob's your uncle. And then you can just rinse and repeat that as for many sub interfaces as you want. This one's just a work in progress. It's just another project. I'm not really worried about that. Anyways, gig 01, which I showed you, it goes to my MDS, and it has an IP address. This is all for NAT, but I'm gonna skip that for a second. All right, so I have a routing protocol configured, and this allows communication between all these networks. I didn't configure BGP, or maybe I did and didn't delete all the configuration. I don't know. Not being used though. All right. And this command right here just says, hey, use this as a DNS server. And so my lab devices are using this router as its DNS server. And this is the command that enables that. But all those other previous commands that I showed you are how you configure the DNS server. Okay, and then I just have a default route. Just says use gig 01, which connects to the MDS. And but I'm going to be using this IP address for its default route, and that is on the Dream Machine. All right, let's see. Yeah, all right, so now let's talk about NAT. All right, so I have my inside devices, like I mentioned, they can, oh, I skipped my interfaces. Here we go. They can ping the internet as I showed. And what I'm using, or how I'm doing that, is using NAT. So instead of letting my Dream Machine handle everything, which I went down that path, I got it working. It was a very funky configuration. I wasn't happy with it. It wasn't very expandable. I couldn't fine-tune it how I wanted to fine-tune the traffic flows. So in the end, I scrapped it, and then I decided, let me just do an all Cisco solution. And so that's what I did. And then everything just worked. And so that's how I did it. I defined all the interfaces, in this case, sub interfaces, I want to use for my inside addresses. So my inside are all my private IPs. And so anything that has that's coming in through this link and is trying to reach something, on the internet, it'll just NAT it. Technically, it's PAT, but anyways. And then I also have this network using NAT. It automatically did that configuration when I did NAT, and I don't remember off the top of my head what it did, but it was very easily researched. But I recommend keeping it in there. Anyways, gig 01, which goes to my MDS. Yeah, I didn't put descriptions on this router like I did on the switch. Oh well. It's doing NAT, but NAT is going to the outside, so that says, hey, everything that's coming from the inside goes to the outside through me. Again, same thing. Make sure that's there. But I also have an access group set up, or an ACL on this interface, and that's access extended. It's an IP extended access list 145. And I will show you what that does. Let's see here. Not those, which I'm going to talk about those in a minute. You know, instead of me doing that, here we go. So if I do show access list 145, it'll show this a lot neater. But this is the configuration. So if these IP addresses are trying to go through gig 01, it denies it. And so what this allows me to do is to have public IPs, which you can see I've got plenty of public IPs. Public IPs on my lab network with no fear of them ever trying to do any kind of DNS resolution on the internet. If I didn't have this here, then they would have a route to, using their IP address, they would have a route to the internet. It's kind of funky. But anyways, and so anytime I add a new network, which I just add on to the access list. It's pretty easy. Now, if I go back up, you'll notice I have a couple more access lists configured. So let me show you those. On IPNAT inside, I'm sourcing the list from Enterprise and VM Network. And then, you know, this is how PAT is configured. And the access list says, hey, I'm just going to permit this guy to be natted. Permit this guy to be natted. That's all it's saying. And so anytime I add a network that's not in the range and I want it reachable to the internet, then I have to add here and I have to add here. And it's pretty simple. Let's see. I don't think there's anything else on the router. Nope, nothing special. Now, the NTP configuration is quite simple. So here I'm saying I want this guy to be my NTP master. I forget what 1 stands for. Let me look that up real quick. NTP master stratum number. Okay, yep. All right, so that's my stratum number. So it says rely on me as a stratum 1, even though it's definitely not a stratum 1. But anything that in my lab that is using this router as its NTP server sees it as a stratum 1. Or that's the theory behind it anyways. Well, I'll check that here in a second. And this router is going to time.nist.gov for its clock. And that can be shown to show NTP associations. You can see here it's local clock, stratum 0, which means, hey, I'm the best. But then it connects to NIST, and NIST is stratum 1. Yeah. So that's good. Let's see here. Oh yeah, and before NTP will work, notice I'm using the host name of the NIST server rather than an IP address, which means I have to have DNS resolution working somewhere, which I've already walked walked you through that, so I'm not going to go over that again. But there's a whole lot of dependencies for all this stuff to work in an all-in-one box. All right, let's test this out. I'm not sure. I don't think this is using it for NTP. I don't know what it is. Maybe. Yep. Yep. So this guy is already set up for NTP. You can see here it's using the all nines IP address, whatever that means, and it is a stratum 2. So yeah, I don't think there's, yeah, yep. So the 999 is stratum 2, which would make sense because it's one more hop. Allow me to demonstrate that on this diagram. I have, well, it's not shown, but we'll use this guy for an example. It wants to reach the lab router. So this guy says he's a 1. And so this guy connects to that guy. And then he increments his counter by 1. But that's how it works. Anyways, and the local 1841 router is a stratum 3. Okay, is there anything else I want to show here? No. Okay, let's talk about vCenter in general. So I have, where is he at? vCenter right here. I have vCenter, and that manages both ESXi servers. And so I'm going to show that now. Yeah, whatever. Don't care. Here we go. The 2 hosts. There are my hosts. Nothing special. All the VNs that they share. Data stores. Networks aren't really important. What is important are distributed switches, distributed port groups, and that's not so important, although it could be, but I don't mess with it. All right, so the first thing I got to do is I got to configure a distributed switch. Once I configure a distributed switch, which here I'll kind of use this as an example. Think of the server 2 as the distributed switch. This distributed switch can have, where are we at? Right here. Can have many port groups connected to it. And so an analogy would be all of these devices, and these are all logical, but all these devices, consider them port groups. And they're all independent of each other, and in order for them to reach any network, they go through the server 2, a distributed switch. Okay, I'm done with that analogy. Now let's bring it back to how I actually have it configured. I have, whoops, no wonder it didn't look correct. I have an enterprise set up, a management set up, and a black hole set up. The black hole is just what it is. If I want traffic to black hole, I'll just use that. Okay. Let's see. Management is just VLAN 1 stuff. It's not a big deal. Enterprise, however, has a lot of port groups assigned to it. And so I can go into that. I think I can click here. Yep. And then click ports. Yep. Wow, that's really small. Let's see if I can make this bigger. Wow, it's really... Oh, well. Oh, I just have to zoom in, I guess. There's a ton, but I'm not using them all. I don't define port IDs. I didn't really define name. But I'm just going to talk about my DNAC right now. So my DNAC is connected to a port group called D Port Group Enterprise. So I can go to that somewhere. I must have passed it right here. I can go to the enterprise and I can see I have a couple, well, 10 exactly, 10 virtual machines assigned to it. But more importantly, it's using, and I'm going to zoom in here, it's using VLAN 5. So if we go back to the diagram, VLAN 5 is our gold link, which I'm calling it enterprise. So anything gold, which is ICE, and the two CSRs right here, because they're including VLAN 5, and the virtual DNAC. So they can all talk to each other in the same network, and they're all happy. I'm going to zoom out again. All right, so, and then just rinse and repeat for any network that you want, and you can expand this as many times as you want. So it's very simple to create it. So first you'll create your switch, and I'm not going to create it, but I'm going to show you how it's done. New distributed switch. So a distributed switch just simply means this switch is identical between both hosts. And again, I have EXXI server 1 and 2. And physically, as far as the NICs go, they are identical. And I'm not even going to experiment with them when they're not identical. So anyways, so they're identical. So that's how I have them set up. All right, so you would go to distributed switch, new distributed switch, give it a name, whatever you want, and then next. Yeah, whatever, it doesn't matter. Next. I leave that alone. I leave that alone. I can either create a default port group or not. It doesn't really matter. And then click finish, and I'm done. And that's how you create a distributed switch. Then once you create the distributed switch, where am I at? Right here. In this case, enterprise. I would just go actions, distributed port group, new distributed port group, give it a name, I didn't want 900. I want, let's do 43. Just a random number. All right. Port binding, just leave that alone. Leave elastic alone. Ports, if you ever need to add more ports, here's where you would do it. Which is, all virtual. Which we can define VLAN type right here. So I would go a VLAN, or you got other choices, but anyways, give it a VLAN ID. What did I call it? 43. And then that's it. You can also do advanced stuff, but I'm not going to. If you wanted to do trunking, then that's how you do trunking. But in this case, I'm just going to do the VLAN 97. Click next and finish. And that's it. You're done. And then all you got to do is go to your host, or not your host, your virtual machine, in which case I'll just show on this guy. Edit it. And then browse. And then find the port group you want. And that's it. And you're connected. Make sure the network's connected. And that's it. That's how you connect it to the network. It's that simple. But that piece has to be done. You have to have a VLAN ID to do the model that I demonstrated. If you don't have a VLAN ID on the port group assigned, but you have the router and the switch and all that's configured, your device isn't going anywhere. It's you're going to give it, the network. You're going to think you're on, whatever network you're trying to create, and it can't go anywhere. It can't reach any device because it needs to be tagged. Anyways, that's how you do it. There's nothing else in here, and so I will show you a couple other things here on this diagram. You see I have ICE set up, or the Identity Services Engine. I've got Eve, which I'm using Eve right now to show this diagram. And then Netbox, and then the two CSRs, which will be part of the DNAC infrastructure. And then external is a physical switch, the 3650. All right, so now I'm going to bring all these together. Let's see, ICE. Where is ICE up here? Right here. It wants me to log in. Okay. Okay. So I'm just demonstrating that ICE is functioning. I'm not going to show how to configure it. This is a supplement to Terry Vinson's videos. That's fine. This isn't a replacement for those videos. So anyways, there's ICE all up and working. No problems there. You can see I'm using the 100.64 range, which is my enterprise, which is VLAN 5. All right, and then I'm using Infoblocks, which I think is, I don't remember what the default is, but I have a program that will auto type it for me. Okay. It's not working. Oh, that's unexpected. Yeah. So it should just be admin info blocks. Yeah, okay. All right. And apparently the page had a refresh. It's probably went stale. Yeah, this doesn't matter. This is just a trial version. So I'll go on status. Of course, info blocks requires services to be used. I'm just using this for an IPAM, an IP address management. That's it. That's all I'm using this for. I'm not using it for anything else. But let's see here. I think it was here. Yep. You see, everything is online and working. And again, Terry Vinson shows how to set this up. So just watch his videos. Let's see here. And then DNA. Okay, DNA was the fun one. Once I got this set up, you can see I can go to software updates. I mean, I already showed you in the CLI, but you can see it's connected to the internet. Otherwise, it would say it's offline. It would have an error message. But I can go to discovery. And I'm not going to go through the discovery process from scratch. I've already got ones defined. But here are my CSRs that I have in my network. And so we'll watch those get discovered. And then I'll do the same thing for the 3650 switch. And I will show the configuration on the 3650 switch. Hopefully this is successful. It was last time. Yep, there we go. Important to note, all these guys are checked. I'm not using netconf, so I'm not worried about that. But anyways, so those are good. We'll go to the 3650. And I'll do a live demo. And I did pray to the demo gods beforehand. So let's see how they received my prayer. Oh, praying worked. Look at that. Okay. So yeah, that's my DNAC working. Yeah, I'm not going to go into anything else. It's not part of this video. This is just showing how to get this stuff initially configured. Okay, so going to the 3650. Nope, that's not the 3650. I can't read. I guess, nope, that's the same device. Oh, there you are. Well, I hope it connects. All right. Why aren't you connecting? Well, whatever. I'll troubleshoot that later. But I can go through the console server, which I think is this guy. Is it? Yeah, it's 26. Yep. Okay. All right, I'll troubleshoot that later. That's just the out-of-band management connection, so that's no big deal. So this is the configuration needed to get this guy up and running. let's see, I'm going to give it, well, actually, let me skip to a certain part of the configuration first. First thing you have to do, well, I can delete that, but we have to define the license, so I'm going to show that section. I guess I could have just done an include, but whatever. All right, so you got to put that, and then you got to reboot it. No sense of doing the entire configuration. Just define a license, boot level of this, and reboot it. Okay, then once you reboot it, we'll go back up here. Then I have, let's see here. None of that matters. I got a domain name configured, so we can do DNS resolution. Skip all this, just self-signed cert stuff. I'm not using it. I have a username configured. This is minimum configuration. And none of that matters. So this gigabit 101, which is in VLAN 5, I showed before. It belongs to this link. So gig 101 is right here. Okay, so going back to that, those other things, they don't matter. There's default configuration on it. I didn't do that. And then I gave it an IP address in VLAN 5 on the interface, and so it's reachable. I said, hey, that's your gateway, which I showed all that before when I showed the lab router. I'm not sure if this was necessary or not, but I did that anyways. I guess I could experiment with it, but it's too late now. I'm not going to redo the video. I told it its default route. I told it source for SSH and gave it version 2. I got to define a source because it's right here. I gave it the 2 SNMP, read only and read write things, and then yeah, see, DNA center 64101, which is right here, 640101. Yeah, so you can see DNA was doing something to it. It wasn't doing any configurations because I didn't provision it and onboard it and do that other stuff. All they did was discover it. And also on the VTY lines, I have login local configured and transport input SSH. And then I've got logging synchronous is just optional. But it's good to keep saying. So anyways, that is that configuration. I guess I'm going to show a couple of extra things when I'm thinking about it. I'm going to show the access list. So show access list 145. You can see this network is quite busy. So that's that access list. And I also want to show spanning tree. First, let me do this right here. It actually, spanning tree is not going to be on the lab router. What am I doing? It's going to be on the lab switch. Okay, so show run includes span. All right, so I'm saying VLAN 1, it's not a priority, but I want to make sure it's not going to be the root. I want my MDS to be the root for VLAN 1. For all other VLANs, and I will add them on as I define them in my lab. It looks like I'm missing a couple, but anyways, it's going to be the root. And I have the other configuration. I'm just going to move this off screen for a minute. And then I am going to pull up my MDS, which I don't know if I need to move this off screen or not, but just in case, I want to show and include span. All right. So you can see here, it's showing priority for all VLANs. However, as I showed in this diagram, right here, only VLAN 1 is going over there. And I already showed with the lab switch that VLAN 1 is, right here. Yeah. Here we go. VLAN 1 is the secondary bridge, so to speak. It's not the root. So anyways, going back to the MDS, I don't think there's anything else special to show on that. Do a quick look around. Yeah, so on my home PC, I just have an IP address that belongs inside the network for VLAN 5 defined on that second NIC, and it's connected directly to my lab switch. And then that's set up as an access port. And I'll show you that configuration, although you have seen it quite a few times. Show run interface. Actually, I'll do first, then show run interface G7. Okay. I call my home PC Derg Home. So that's the second NIC. That's the IP address I gave it. It's in VLAN 5. That's it. Nothing special. But this allows me to do, from my PC, connect into any one of my networked devices in my lab without having to do something funky. Yep. Let's see. Anything else I want to show? I guess no. That's it. That's all I want to show. All right. Thank you for viewing. I hope this has been very helpful. I spent a lot of time, a lot of troubleshooting, trying to figure out ways to optimize this. There might even be a better way. But this is the simplest way that I could come up with without spending any more time. I already spent way too much time trying to do it through the Dream Machine, using that guy as my lab router. Like I said, I had it working, but I was not happy with it whatsoever. It was very, very awkward configurations. You didn't really, when you put something in, if it worked, great. If it didn't work, you didn't really get any output messages like you would on a Cisco device telling you, hey, this is why it's not working. There's nothing like CDP neighbors. None of that stuff exists. And so anyway, so this is how I got it set up. Have a good day.